Today, we're looking at a breakthrough that sounds like pure science fiction, a material that can pull drinkable water straight out of the bone-dry desert air. It's called a MOF. And after winning the Nobel Prize in 2025, it officially being hailed as the silicon of a brand new materials age. Metal organic frameworks, or MOFs, are essentially molecular sponges that scientists can program to trap specific molecules like water, carbon dioxide, or hydrogen. Because they are incredibly porous, with just a few grams covering the area of the size of a football field, they are likely the key to solving global water scarcity and stopping climate change. What do you think about this, John?
I think this is cool. And I like, as we started talking about it, I feel like we've covered something similar, but I don't know if it was organic and metal merging, but this isn't that. But anyways, we talked about water from the air in the past, but anyways, this is something different. We're talking about metal organic frameworks. And so they're crystalline materials that are made by linking metal ions with organic, we'll call them linker molecules, that into a pattern. It's like a lattice-like structure, and they have these huge internal cavities. So unlike traditional solids, most of an MOF's volume, it's pretty much empty space. So it gives us this huge, colossal surface area relative to its mass. And so this internal porosity, that is what enables the MOF to physically or chemically bind gases and liquids with high selectivity. And so the other cool thing about this is that these pores can be tuned at the molecular level. So by selecting different metals, different linkers, and geometric arrangements, scientists can design MOFs to target specific molecules. So for example, capturing carbon dioxide while letting other gases pass, or like you said, absorbing vapor efficiently, even from dry air. And so this design flexibility, it's foundational to reticular chemistry, which is the field that Yagi kind of founded, which builds complex materials from smaller components with engineered function. So I agree with him saying that these are going to be a game changer and they're going to change the world. I think if they're able to produce these at mass scale, and get it into a third world country and where we need, I think this could be a game changer for reducing carbon dioxide and enable better drinkable water for people. What do you think, Craig?
I think this is an amazing evolution of material and a bunch of different things. It's going to rapidly change some fields. I like to think of it as molecular Lego sets. Instead of plastic blocks, scientists use metal atoms and organic linkers to build tiny 3D structures with massive amounts of empty space inside. So if a normal material is like a solid brick, a MOF is like a skyscraper where every single room is designed to hold a very specific gas, like a water molecule or a CO2 atom, like you're suggesting. So the big deal is this is, an unprecedented surface area. The internal floor space inside these materials is, just mind-blowing. And for the first time, we aren't just finding materials in the nature, we're coding them at the atomic level to do specific jobs. So, that's amazing. And this isn't just a lab experiment anymore. With the Nobel 2025 Prize, it's recognized as a fundamental chemistry that will define the next century. So, yeah, I think this is crazy. And I see applications like we're suggesting, cleaner air, using industrial plants use MOF filters to scrub carbon dioxide out of the air before it ever hits the atmosphere. Better electric vehicles feature EVs could store hydrogen or methane much more safely and densely, leading to longer ranges and faster refueling. Water out of thin air, obviously I mentioned, you could have a device at home that generates gallons of fresh water every day, even if you live in a desert using only sunlight. So, just those are just some ideas.
Yeah. And the thing about this is that, I don't know if we touched on this, but he won a Nobel Prize for this. So the prize itself isn't about prestige. What this prize signifies is it signals that this isn't just fringe research. It's foundational science with real potential to alter how we address climate, water, and energy challenges. So his vision ties back to a social mission, material science that alters societal infrastructure and not just lab benchmarks, which I love. And so being positive, I'm being really positive about this, but there's a few things. Despite their promise, they're not a finished commercial product. And so the greatest challenges, like I alluded to a little bit earlier, was scaling synthesis to industrial volume. The other challenge is ensuring long-term durability and also integrating them into processes that can compete economically with already incumbent technologies. So the positive on this is that the pace of research, which obviously they're including machine learning driven discovery, it suggests that there's going to be rapid progress on this to a commercial viable product.
Yeah, I mean, companies are already field testing water harvesters in places like the Arizona desert. We'll likely see MOFs appearing in specialized industrial gas sensors and high-end purifiers within the next couple of years. And then between the 5 and 10 years, we'll see mass market consumer products like home water generators or CO2 scrubbing HVAC units are on the horizon as manufacturers starts to scale. There's still some concerns about cost. Currently making the links for these frameworks is expensive, often requiring a complex chemical synthesis. Durability, early versions were sensitive to moisture. It's kind of ironic, but though newer zirconium-based versions are much tougher. And scaling, they need to go from making grams in a lab to millions of tons in factory to truly save the planet. And kind of reminds me of, the football field in your pocket. A tiny nugget of MOF5 has more internal surface space than a full-size football field. It's like, are we in the Frank Pym age where we pull something out and go boom and it becomes huge?
Yeah. Exactly. Did you find anywhere where they talked about cost to produce this or commercial cost or anything like that? I'm guessing not, because it's still in the research phase, eh?
The only thing I really have is that it's expensive right now. It's expensive to make them. Because of the links for these frameworks is expensive after requiring complex chemical synthesis. But once they kind of have it nailed down, I think it'll scale.
Yeah, for sure. It makes sense. It's not like they're inventing new metals. It's not like they're creating metals that need to be created like by combining others. Like, it's not like they're doing things that aren't viable or feasible, if that makes sense, with this technology.
Yeah, and it's really good at, say, detecting differences between nitrogen and CO2 and being able to pull out the CO2 as an example, if that's what we're aiming for. So It's really cool. And the previous versions, the DOFs, the difference basically was they didn't have any metal, and the new ones contain metal.
Okay.
So we'll see how that goes. I'm just trying to see, did we miss anything? I don't think so.
No, we covered everything. This is great. By the way, I think he won the Nobel Prize in 2025 for this. So this isn't old news. This is new news, newer news, if that makes sense.
So is this the end of water scarcity or just an expensive lab dream? Given the Nobel win and the desert test results, I'm betting on the future. Let me know in the comments. Would you trust a device that makes water out of thin air? We'll keep watching this story closely. What do you got going on, John? This is stuff that's going out in the next week or so.
Yeah, so we've got some events at the Toronto Business Development Center. I'm doing some lunch and learns in person there. It's a great organization, great incubator. And then February, what date is the Startup Drinks, Craig?
I closed that, so I'm not sure. February 19th, I believe.
February 19th, but have a look at startupdrinks.com, startupdrinksto.com for that event and other events. If you need some help with government funding, SHRED, or any other grants, reach out to me on LinkedIn. But if you're interested in AI automation workflows or you need help with your business, what can they do, Craig?
Well, we've got lots of stuff going on over at flowgrammar.ca where we help businesses implement AI and business automation so they can scale faster and more reliable, get more leads, grow faster. We also have a growing community over at flowgrammars.ca where we do Flow Grammar Cafe, we do live build events, we do demo events, we get the community together online and in person several times a month to show and demo and support anybody who's trying to do this, learn automation, end-to-end AI agent building. So check all that out. We have a series of events called Flow Grammar Cafe. The next one's February 6th, March 6th, and April 2nd. We do those right now in partnership with Workhouse, and those are full day drop-in headphones, laptop, and work. And we'll have some experts on site that can help you troubleshoot. And we all kind of do a little walkthrough in the afternoon about what you're working on, and show us what you're working on and stuff. And it's really cool. So check all that out over at flowgrammar.ca and flowgrammars.ca. And coming soon, and you can sign up for this now, flowgramming.space. An AI agent and workflow marketplace where people can buy and sell agents or workflows. So if you're building agents and don't know what to do with them, where to sell them, go over there and check that out. Again, flowgramming.space. Or if you're building workflows, or if you want agents or workflows built, you can go over there and buy them. We have some interesting guarantees, and it's coming soon, so you can get your name on the waiting list right now. That's all we got going on, John. For everything else, go to torontostarts.com. I don't even think I mentioned it that whole time. Thanks everyone for watching. All the information about CES, and these interesting things. Any last words, John?
No. Check out our next episode. We're going to be talking about the weird stuff at CES. So,
all right, everyone. Thanks for watching.